Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 10 video from the chapter of coordinate geometry, I will discuss about the concept of finding the conditions of 3 points to be collinear. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so the question is that we are given 3 points P, Q, R. The coordinates are given. The coordinates of the point P are x1, y1. The coordinates of the point Q are x2, y2, and the coordinates of the point R are x3, y3. And we need to check whether these 3 points are collinear or not. 2 points are always collinear in the Cartesian coordinate system, but to check whether the 3 points will be collinear or not, that is the question. Now, first of all, we will check the very special cases. Case 1 is that if abscissa of all the points are equal, if x1 is equal to x2 is equal to x3, then this will imply that the line joining, this will imply that P, Q, R are obviously collinear, and the line joining P, Q, R will be parallel to y-axis. So they if the abscissa of all the 3 points are equal, then they will lie on a line which will be parallel to the y-axis. So this is case 1. Case 2 is if ordinates of all the points are equal, that is y1 is equal to y2 is equal to y3, then this will imply that P, Q, R are also collinear, will be collinear, and line joining them is parallel to x-axis. So if the ordinates of all the 3 given points are same, then they will obviously lie in a line which will be parallel to the x-axis. So these are 2 special cases. There is another third special case, is that okay, now it could be the fact that the points P, Q, and R, they are collinear and they are lying on a line which is passing through the origin, but the line is not the y-axis or the x-axis. So they could lie on a line which passes through the origin, that is that is the point having coordinates 0, 0, but that line is not the y-axis nor the x-axis. So the equation of that line is of the form y equals to kx, which I discussed in the previous video. Now, so if you see that now so any point, any point lying on this line, any point lying on the graph of this line, that is y equals to kx, where k is not equals to 0 and k is a real number, real constant, then all the points, then the points lying on this line will satisfy. That is if the points P, Q, and R is if they are collinear and they lie on a line whose equation is of the form y equals to kx, then we will have the ratio of the ordinate and the abscissa will, for all the 3 points, will be same. That is y1 by x1 will be equal to y2 by x2 will be equal to y3 by x3. But remember that you will check only when x1 is not equals to 0 x2 is not equals to 0 and x3 is not equals to 0. The points given PQR, if their abscissa are all the abscissa are non-zero, then you can check this condition. If y1 by x1 is equal to y2 by x2 is equal to y3 by x3, then this will ensure that the points PQ and R are collinear and they lie on a line of the form whose equation will be y equals to kx, and that line will pass through the origin. So this is the three special cases. If none of these cases works out, then you can check whether the points PQ and R are collinear or not by this formula. You take 2 points at a time. Let's say I am taking PQ and let's say QR. You can take PR and QR. So take 2 points at a time, and then if you see, so for the points P and Q, what you do is you take the ratio of the difference of the ordinates and the difference of the abscissa. So the ratio for the points P and Q will be y2 minus y1 divided by x2 minus x1. Remember that y2 x2 comma y2 are the coordinates of the point Q, and y1 comma x1 are the coordinates of the point P. So I am considering the points P and Q, I am finding the ratio of the difference of the ordinates and the difference of the abscissa. So when you are taking the difference y2 minus y1, then the difference of the abscissa has to be x2 minus x1. It cannot be x1 minus x2. Okay, now similarly for the points Q and R, it will be, this ratio will be y3 minus y2 divided by x3 minus x2. Now if these two ratio becomes equal, this will imply that P, Q and R are collinear. But here also, what if x2 minus x2 is equal to x1? What if x1 is equal to x2? Then it will be problem, because x2 minus x1 will become 0, and division by 0 is not allowed. I use this condition. You check the condition 4 only when you will see that x2 minus x1 and x3 minus x2 are not equals to 0. Now I have considered the points PQ and QR. You could have also considered the points PR and QR, or you can consider the points. Yes, these are the two possibilities: PQ and QR or PR and QR. So if you consider the points as PR and QR, then the ratio for the points PR will be y3 minus y1 divided by x3 minus x1, and the ratio for the points Q and R will be y3 minus y2 divided by x3 minus x2. So the case 4 you can check only when the all the abscissa of the 3 points are different. Then then the difference of any two abscissa will not be equal to 0. So these 4 cases, using these 4 cases you can decide, you can check whether the 3 points are collinear or not. The first two are very simple. If the points PQ and R have the same abscissa, it will mean that they lie on a line which is parallel to the y-axis. So they will be collinear. In case 2, if the ordinates of all the 3 points are same, then it will mean that they are collinear, they lie on a line which is parallel to the x-axis. And the case 3, if you see that x1, x2, x3 are non-zero, and if you find y1 by x1 is equal to y2 by x2 is equal to y3 by x3, then it will mean that the points p, q and r are collinear and they lie on a line whose equation is of the form y equals to kx, that is a line passing through the origin. And case 4, you can check this condition considering taking 2 points at a time, but make sure that the difference of the abscissa of any 2 points is not equal to 0. So using these 4 cases, you can check whether the 3 given points are collinear or not. Even though I have plotted some points in the Cartesian plane, I was planning to, okay, let's see, as you can see that the points A, B and C, they all have the same ordinates minus 3. So A, B and C will lie, they are collinear, they will lie on a line which will be parallel to the x-axis. Similarly, you will see the points the G is 1, 2, but again I have plotted G as 1, 0. So let's say this be the point I. So if you see the points G, I and C, the coordinates of the point G are 1, 2, the coordinates of the point I are 1, 0 and the coordinates of the point C are 1, minus 3. The abscissa of all the points G, I and C are equal, that is 1. So they will be collinear. If you join them, they will be on a line. They all will lie on the same line, which will be parallel to the y-axis. Similarly, if you join, yes, I think these are the 4 conditions using which you can check whether the 3 given points are collinear or not. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. There are lots more concepts to discuss, so I will discuss them in the future videos, so please stay tuned. I am ending the video here. Thanks for watching, and until the next video, take care and bye.